Hello, everyone, and welcome. I'm excited to kick off our session today with an introduction to programming concepts using Scratch. On this first slide, you'll see the title, An Intro to Programming Concepts with Scratch. We'll also briefly explore what you'll learn in this presentation, including the basics of programming, how Scratch makes coding fun and accessible, and some practical examples. So let's get started and enjoy the journey into the world of programming. Let's take a quick look at the contents of today's session. We'll start with understanding what Scratch is and why it's such a valuable tool. Then, we'll explore the basic interface to get familiar with how Scratch works. Next, we'll dive into the concept of programming itself, making it easy to grasp. After that, we'll see how to get started with Scratch, including how to find it and set it up. We'll also go through some step-by-step instructions to create a fun project, like making a dancing cat. Along the way, we'll learn about using the green flag to start your projects and how to add backgrounds to make your creations more lively. This overview sets the stage for a hands-on journey into coding and creativity with Scratch. So let's talk about what Scratch actually is. Scratch is a free software development kit, or SDK, that's designed to be object-oriented. It's aimed mainly at children between the ages of 8 and 16, but it's really powerful enough for creating all sorts of projects like animations, interactive stories, games, and even music. The best part is, you don't need to know any specific programming language to get started. You can use Scratch either online through a web browser or download it and use it offline on your computer. The online version is accessible at Scratch, Mit, Edu, and if you prefer working offline, you can download it from the same site. Now, one of the most important things to understand about Scratch is that it doesn't require you to learn syntax, which can often be a barrier in programming. Instead, you build your programs by dragging and dropping blocks, making it very intuitive. This block-based approach allows you to focus on logic and creativity rather than syntax errors. Despite its simplicity, Scratch is capable of creating quite sophisticated programs. It's not just for beginners or kids. Many experienced developers use it to prototype ideas or teach concepts because it offers so many building blocks. You can explore and combine these blocks to craft complex projects. And the extensibility of Scratch really opens up endless possibilities. Many users might not realize they can add variables, lists, or even create their own custom blocks within the environment. Plus, Scratch can connect to hardware like Lego or Roboblox, which means you can integrate physical devices into your projects. This flexibility makes Scratch a powerful tool for both learning and creating, regardless of your experience level. So, what is Scratch exactly? Scratch is a simple, user-friendly environment created by the Kindergarten Lifelong Learning Group at MIT. It's designed to make learning programming fun and accessible for everyone. In Scratch, you work with sprites, which are basically objects or characters, and you manipulate them on a stage, which serves as the background for your project. You do this using small pieces of code called scripts. Think of them as tiny program segments that tell the sprites what to do. Each sprite has its own set of scripts that control its behavior and how it interacts with other sprites or responds to different events. It's like giving each character its own set of instructions, so they can act independently or work together. The key idea is that programming in Scratch is all about snapping together blocks of pre-made actions to create a script. These blocks can be as simple as one action or combined into multiple blocks stacked together, forming a more complex program that runs as a unit. Overall, Scratch is a fantastic way to introduce basic programming concepts in a fun, interactive way, making it easier to understand how coding works by visualizing and controlling characters in a creative environment. So, what exactly is programming? Well, at its core, a computer program is really just a set of instructions. Think of it like a recipe for a cook. It's telling the computer exactly how to make something happen. Programming is essentially the art of making a computer do what you want it to do. It involves creating clear, step-by-step instructions that guide the computer through a task. This way, we can harness the power of computers to solve problems, automate tasks, or create amazing applications. Remember, at the heart of programming is communication, writing instructions that the computer can understand and follow precisely. So why do we focus on Scratch? Well, first, it helps kids become fluent with digital media. That means they can create, understand, and interact with digital content confidently. It's also a fantastic way for them to express themselves creatively, whether through stories, games, or animations. But it's not just about creativity. Scratch also helps students make meaningful connections to powerful ideas. They learn to see how different concepts fit together and relate to real-world problems. And importantly, it introduces them to key computational ideas, like algorithms and debugging, in a way that's accessible and engaging. Finally, Scratch encourages systematic reasoning. Kids learn to think logically, plan their projects step by step, and solve problems methodically. Altogether, these points support our broader goal, empowering kids to navigate and thrive in a digital world with confidence and critical thinking skills. All right, so now that we've covered the background and the key concepts, it's time to get started. This slide is all about taking that first step and putting everything we've discussed into action. Remember, the goal here is to move from theory to practice. We'll want to focus on the most important points, like identifying your objectives clearly, understanding your audience, and setting realistic milestones. These are the building blocks that will guide your progress. And as we move forward, keep in mind how this fits into the bigger picture, building a sustainable, effective approach that you can carry out confidently. So, let's embrace this starting point and get ready to make meaningful progress. Let's take a closer look at the basic interface. On the stage, you see the area where your sprites perform and interact. It's like the stage in a theater, setting the scene for your project. Next, we have the block description section, which explains what each coding block does. Think of it as the instruction manual that helps you understand how to use the blocks effectively. Then there's the script area, where you assemble your blocks to create your program. It's the workspace where the magic happens. Finally, we have the sprite list, which displays all the sprites in your project. You can select, add, or modify sprites directly from here. Understanding these core components is essential because they form the foundation of how you build and organize your projects in this interface. Each part plays a vital role in making coding accessible and engaging, helping you bring your ideas to life smoothly. Now let's take a look at the menu. This is where you can manage your projects easily. You can create a new project, open an existing one, or save your work, whether it's saving over the current project or saving a new version under a different name. If you accidentally make a mistake, the undo option lets you go back to a previous step. And of course, if you need assistance or guidance, the help feature is there to support you. You'll also notice that the blocks are all color-coded by category. This visual cue helps you quickly identify the type of block you're working with, making it easier to navigate and build your projects efficiently. These features are designed to streamline your workflow and keep everything organized, so you can focus on creating without unnecessary distractions. Now, let's talk about the green flag and red stop sign, which are fundamental controls in most programming environments. Typically, you click on the green flag to start your main program or scripts. It's like hitting the play button to begin your project. On the other hand, the red stop sign is used to end or halt the program when you're finished or need to pause. These controls make it easy to manage your program's flow, especially when you're testing or demonstrating. Remember, the green flag signals go, and the red stop tells your program to stop. Using these controls consistently helps keep your projects organized and easy to manage. They're essential tools for controlling your program's execution, making your coding experience smoother and more intuitive. Learning to Scratch is all about trying things out and experimenting. Since it's an interactive environment, I encourage you to stop and play around as you go through this tutorial. It's a great way to learn. When it comes to writing simple scripts, the process is quite straightforward. You just drag a block from the blocks palette and drop it onto the scripts area. Once you have your script set up, you can run it by double-clicking the block. Watching what happens on the stage is a key part of understanding how your code works. Remember, the numbers you use can be integers, which are whole numbers. This simple approach helps you get comfortable with the fundamentals of programming in Scratch. Keep experimenting, and you'll build a solid foundation for more complex projects as we continue. All right, let's talk about the training objective titled Dancing Cat. The main goal here is to illustrate how we can teach a model to recognize and generate complex, coordinated movements, kind of like a cat dancing. This isn't just about simple recognition. It's about capturing the nuances, rhythm, and timing involved in such dynamic actions. By setting this as our training objective, we're pushing the boundaries of what AI can learn about motion and behavior. This ties directly into our overall theme of advancing machine learning capabilities in understanding and replicating real-world activities. Essentially, we're aiming to develop systems that can interpret and even imitate intricate human or animal motions, which opens up exciting possibilities for applications in entertainment, robotics, and beyond. All right, let's walk through some simple steps to make our program more fun and interactive. First, double-click on the desktop icon to open our project. Once it's open, the next step is to add a sound. This will really bring our character to life and make the experience more engaging. After that, drag a move block into the scripts area. This is where we'll tell our cat how to move. When you click on the move block, you'll see the cat move on the screen. To make it even more exciting, drag a play drum block and snap it onto the move block. This way, when the cat moves, it will also play a drum sound, adding a lively touch. These steps are key because they show how to combine motion and sound, which is fundamental in creating dynamic animations. Remember, connecting the sound with the movement helps to tell a more complete story and keeps your audience engaged. So by following these steps, you're learning how to make your projects more interactive and fun. All right, now let's take a look at what's happening behind the code. Here, we're dragging out a play drum block and snapping it onto the move block. This is how we tell our program to play a drum sound when the sprite moves. Go ahead and click on the block to listen to the sound it makes. If you don't hear anything, check that your computer's sound is turned on and the volume is up. One of the great things about this setup is that you can choose different drum sounds from the pull-down menu. So, you can customize the sound to match what you want your program to do. This part of the project really highlights how we're connecting code with actual sound effects, making our program more interactive and fun. Remember, understanding how these pieces fit together helps us see the bigger picture of how coding can bring animations and sounds to life. All right, now let's talk about starting a dance. To do this, we add another move block to our sequence. Simply click inside the block and type a minus sign. This minus sign acts as a command to reverse or stop the current movement, giving us more control over the animation. Once you've added the block, you can click on any of the blocks to run the entire stack and see how your changes work in real time. To make our dance more lively, let's add a play drum block. Just select it, then choose a drum sound from the menu that appears. Clicking to run this part will trigger the drum, adding rhythm to our dance sequence. These steps are essential because they show how simple commands and adding new blocks can create more dynamic and engaging animations. Remember, the key is to experiment with different blocks and timing to make your project as expressive as possible. This approach ties back to our overall theme of building interactive and fun coding experiences. Let's take a closer look at the idea of again and again. This concept really emphasizes the importance of repetition in learning and mastery. When we repeat actions or ideas consistently, it helps to reinforce those neural pathways in our brains, making the skills or knowledge more ingrained. This is essential for long-term retention, not just short-term recall. Repetition also builds confidence. The more we practice something, the more comfortable we become with it, which ultimately leads to better performance. It's a key strategy that supports our overall theme of continuous improvement and mastery. So, whether we're talking about developing a new skill or refining existing ones, the message here is clear. Consistent, deliberate repetition is a powerful tool in achieving success. It's about creating habits that push us forward again and again until excellence becomes second nature. Whenever you click the green flag, your script will start. This is the signal to begin running your project or program. Think of the green flag as your go-ahead, a simple but effective way to initiate your work. To stop, just click the stop button. That's your quick and easy way to halt everything when you need to or when you're done. This setup makes it straightforward to control your project, especially when you're testing or demonstrating. Remember, the green flag and stop button are your main tools for starting and stopping smoothly. They help keep your workflow organized and easy to manage, which is essential in any project. So, always keep in mind how these controls connect to your overall goal of creating a seamless and user-friendly experience. Let's move on to slide 16, which is about adding a background. When you're working on your presentation, choosing the right background is key. It helps set the tone and can make your content more engaging. Think about how the background complements your message, whether it's a subtle color that doesn't distract or a relevant image that reinforces your point. It's important to highlight that a good background should enhance readability, so always consider contrast. If your text is dark, go for a lighter background and vice versa. Also, keep it consistent throughout your slides to create a cohesive look. Remember, the goal is to support your message without overwhelming it. When done thoughtfully, adding a background can really elevate your entire presentation and make it more memorable for your audience. Now let's talk about where you can find Scratch. You have two main options: the online version, which is available at Scratch, MIT, Edu, and the offline version that you can download from Scratch, MIT, Edu/download. If you're working offline or want to use Scratch without an internet connection, the download is the way to go. To run the offline version, you'll need Adobe Air, which you can get from Get Adobe Com Air. Just a quick note, making sure you have the right requirements helps ensure everything runs smoothly. Also, there are some great support materials to help you get started. These include Scratch 2 starter projects, a Getting Started guide for Scratch 2, and Scratch 2 cards. And remember, the best way to learn is by trying your first project. So I encourage you to dive in and experiment with creating something new. These resources are here to support you every step of the way.